This is the first video on chapter 28, slope of the tangent line. And theorem 236 essentially says that the derivative is the slope of the tangent line. So we draw the tangent line. I have two lines here, but we're looking at the tangent line at the point C, f of C. And that is the one that I've labeled L sub t for tangent. So this is our tangent line. It comes through right here, and it just hits the curve, hits the graph of this function in one point. And I've labeled this L sub t, and its slope is m sub t. And basically what theorem 236 says is that m sub t is the derivative of f at c. And what I've done here is I've drawn a picture, and I'm going to explain why that is. So what we did is we picked another point right here, x, not equal to c. And we looked at f of x, that is the function value right here. So this is the point x, f of x. This is the point c, f of c on the graph of the function. Both of these points are on the graph of the function. We're interested in the point c, f of c though. We pick another point just pretty much arbitrarily, and we make it kind of close to c. And I'll tell you why we make it kind of close to c at first, or later. So here's our point x, f of x. And we draw the line through these 2 points. Remember, 2 points define a line. And we notice that these lines are kind of close to each other. They're similar. We're going to call the slope of this line m sub 1. And what we notice then is that m sub t is similar to m sub 1. It's approximately m sub 1. How good of an approximation it is depends on how close x is to c. But we're going to say m sub t is approximately m sub 1. M sub 1 we can actually calculate, right? It's the change in the y coordinates divided by the change in the x coordinates. So we have f of x minus f of c divided by x minus c. This is the slope of L sub 1. So this m sub 1, this is the slope of L sub 1. It's approximately the slope of the tangent line. Okay? But we don't want to know approximately what the slope of the tangent line is. We want to know what's the slope of the tangent line. So what we do is we decide that we'll take x closer and closer to c. We'll make x arbitrarily close to c, but not equal to c. Because if x were actually equal to c, we'd be trying to find the line between 2 points that are the same. Also, when we calculated the slope, we would be dividing by c minus c, which is 0. So we want our points to get very, very close to c, but not actually equal to c. What is that? That's the limit. The limit as x approaches c. This says x is getting very, very close to c, but it's not actually equal to c. This is the very definition of limit. Then we calculate these slopes. F of x minus f of c divided by x minus c as x gets arbitrarily close but not equal to c. That is the slope of the tangent line. So what we're doing here is we're taking these x's, we're getting very, very close to c, coming along this curve. So remember, we're evaluating f at x. So we're looking at the points x, f of x. So these points are actually on the graph of the function, and these points get very, very close to c. And we take this limit, and then we say, what is this limit? We recognize this. The limit is x approaches c of f of x minus f of c divided by x minus c. That is the definition of derivative. This is how we define the derivative of f at c, as the limit is x approaches c of f of x minus f of c divided by x minus c. So that's why the derivative is the slope of the tangent line.